So guys, today we'll discuss about configuring inter-VLAN routing. So what is inter-VLAN routing, its working, and why we need inter-VLAN routing. Before starting the inter-VLAN routing, we should know the facts of VLAN. By default, the hosts that are the member of same VLAN can communicate with each other. What's the mean of it? That means the member of VLAN 2 means I'm talking about this. The member of VLAN 2 will be able to communicate within the VLAN 2 only. So the member of VLAN 2, suppose this is the host B is there, host A is there. So these all members will be able to communicate within the VLAN 2 only. The member of VLAN 3, suppose I'm talking about this one. The member of VLAN 3, how many members are there? Here you can see two members are there. Host C and host D is there. So host C and host D will be able to communicate within the VLAN 3 only. Right? The member of VLAN 2, suppose this VLAN 2 is there and VLAN 3 is there. So the member of VLAN 2 will not be able to communicate with the member of VLAN 3. What do you mean? It means suppose host B wants to communicate with host 5, that is not possible. So this will not allow to communicate, right? So this is the drawback. This is the drawback you can say that VLAN is having, right? Next it is layer 2 switch cannot forward traffic between VLANs without the assistance of router. They can transfer the VLAN. They can transfer the packet, they can transfer the traffic from one VLAN to another. That is possible, but it need router or layer 3 switch. So you need router assistance, and layer 3, if you have layer 3 means routing capability should be there, then only it is possible to communicate. Inter-VLAN routing is a process for forwarding network traffic from one VLAN to another using a router and layer 3. Same I told you. So you need router and layer 3 switch if you want to transfer the packet from one VLAN to another. So suppose VLAN 2 wants to send the packet to VLAN 3, means suppose host B want to send the packet to host D, and host B wants to send the packet to host E. So if they want to send the packet, then only it is possible to transfer with the help of inter-VLAN routing. It is possible. Next, if you are inter-VLAN routing, use VLAN trunking and sub-interface. So we are going to use these two very important things, trunking and sub-interface. We need these two components, VLAN trunking and sub-interface. Through that it is possible to do the inter-VLAN routing, right? The physical interface of router must be connected to a trunk link on the adjacent switch. What do you mean it? So in diagram you can see one router is there, this one is one router is there, L2 switch, one L2 switch is there, one hub is there, you can see at this point, and three VLANs we do have. So how many VLANs we have? Three VLANs. So one VLAN, two VLAN, another in three VLANs. So we do have a three VLAN, right? So one router, one switch, one router, one switch, and one hub is there, and we do have a three VLANs, VLAN 2, VLAN 3, VLAN 4, right? VLAN trunking allows single physical router interface to route the traffic for multiple VLANs. What actually this is saying? So VLAN trunking allows single physical router. This is the single physical router interface. Talking about this one interface to route the traffic for multiple VLAN. These, with the help of this router and single physical interface, you will be able to send the traffic. You will be able to start the traffic from one VLAN to another VLAN, and you need one trunk port at this switch also. So that we'll discuss. So with the help of physical on the router, sub interface will be created. In this router, what will happen? You are going to use one physical interface, but this physical interface will be divided into multiple sub interface as per the VLAN. So number of VLAN is equal to number of sub interface. Suppose you have a 3 VLAN, so you need 3 sub interface at this point, right? So we'll learn how we can create the sub interface part. So we'll learn about that. Each sub-interface is assigned IP address is specific to its subnet of VLAN. So every VLAN will be assigned some IP, and according to that IP address, you have to configure that IP address at this subnet sub interface, right? So we learn in lab. Next, it's very important that VLAN information method means it's very important how switch will identify which frame belong to which VLAN. Suppose you are going to transfer the packet from one VLAN to another, but how switch is going to understand this packet belong to which VLAN. This can be achieved by two methods. So we are going to learn this can be achieved through two methods, ISL and IEEE 802.1q method. So we have to learn about the ISL and we have to learn about the IEEE 802.1q. So first of all, I'm going to discuss about the ISL. This is the header, ISL header. So ISL this is full form of inter switch link. ISL is a way to tagging VLAN information. So ISL is going to use tagging. What is tagging? Tagging means it is going to write the information, and that information will help the switch to handle the traffic from where it is coming and for which VLAN it is coming. So ISL is going to maintain all this information, and this information will be mentioned in tag. This allow a switch to identify the VLAN membership that I told you of a frame received over the trunk link. So whatever frame it is going to receive at trunk link, trunk port already you have configured at switch. So it will understand from where this will packet is coming, from which VLAN this packet is coming, and from which VLAN I have to deliver this packet. By running the ISL, you can interconnect multiple switches and still maintain the VLAN information. So by running ISL, you can interconnect multiple switches and still you maintain the VLAN information. So VLAN information will be maintained. ISL is a proprietary protocol to Cisco. So it is developed by the Cisco. So it is the proprietary protocol. What is the proprietary protocol means? Proprietary protocol means the sense no other vendor can use this ISL, right? Except Cisco. But Cisco use mostly 802.1q. So Cisco using IEEE, that is open source created. So IEEE 802.1q, 802.1q it is using. Mostly it is using here, but it has own protocol, that is ISL, for the same purpose, right? Next it is we have to discuss about the IEEE 802.1q and its sub interface, right? How sub interface will be managed. So this is the header of 802.1q. 802. Created by IEEE. IEEE is one organization. It is open standard protocol. So anyone can use this or IEEE. Anyone, this is any switch, any manufacturer can use this. It add the field into the frame to identify the VLAN. It add its own frame to identify the VLAN. Through that, switch can understand for which VLAN it is packet is coming. All traffic of native VLAN is untagged. One very important thing. One question is there: what is native VLAN? So all traffic for a native VLAN is untagged. Frame is not tagged for native VLAN. That is very important. Suppose you do have a switch, and if any frame is coming from native VLAN, so frame will be untagged. Means frame will not going to be tagged. Then how switch will understand from where the packet is coming and where you have to deliver. So by default, VLAN 1 is a native VLAN in all switch. So suppose you have a switch. So by default, native VLAN VLAN 1 is a native VLAN by default. Or you know very well. But if you are going to use switch, you will find that one by default VLAN is created, that is VLAN 1, and VLAN 1 is configured to native VLAN. And the purpose of native VLAN is if any packet is going to be generated from VLAN 1 and it is delivered to the trunk port, then switch will understand if tag is not there, in the sense that packet should be given to the VLAN 1, right? Is native VLAN in all switches. If any frame received untagged or at trunk will be given to the VLAN 1. So you have to understand about the native VLAN. To support ISL or 802.1q, that is IEEE 802.1q routing, the router interface is divided into logical interface one of each VLAN. This is called sub interface. So you have to create sub interface to understand the 802.1q or ISL. So as I told you, one physical interface of router will be directly connected to one switch port, and that switch port is going to be marked as a trunk port, right? And that trunk port uh, will be using ISL and or IEEE 802.q, and with the help of sub interface according to the VLAN, you are going to create the sub interface on router to identify the every VLAN, right? Next, it is from a fast Ethernet or gigabit interface. You can set the interface to trunk. You have to make the trunk port as I discussed. So, if you're what command you have to run at router, you have to enter into global conversion mode. You have to enter into this 0.1. Previously we was not using any dot one, so here f0 oblique 0.1 is there. In the sense, this is the sub interface, and you have to run encapsulation dot 1q and VLAN ID. Suppose you are configuring so VLAN 2, so you have to provide encapsulation dot 1q 2, right? And how to create the trunk port and switch. So you have to enter into switch global conversion mode. You have to enter into one interface where you have connected the router physical interface, and you have to run the command switch port mode trunk. That much enough. And this is the sub interface you have created. Means one only at the switch you are using one physical interface, that is f0 oblique 0, g0 oblique 0, and g0 oblique 0 is divided into three logical interface for three VLANs, right? Now, key point for L2 switch configuration. Suppose you are going to configure L2 switch. So how you are going to configure? So the router is connected to the switch using sub interface. So router is going to be connected to the switch through sub interface. One physical interface will be connected, but according to the VLAN you have to create the switch. The switch port connecting to the router should be in trunk port. So as I discussed you, if you are going to connect the switch with the help of to the router, so that port will be configured as a trunk port. The switch port connecting to the host and hub are access port. So trunk port and access port, two port are there. Trunk port will be carry data of all VLAN. Access port carry the data of same VLAN. So if router and switches is going to be connected at trunk port, and VLANs and host is going to be connected at access port, right? So how, just you see how we are going to configure. So at switch I'm going to run the command at this switch. See, 2960 is there. Config global conversion, we have entered into global conversion mode, and suppose I'm going to configure interface 0 oblique 1. So this is the 0 oblique 1, and in 0 oblique 1 is going to be marked as a trunk port because directly router is connected to the switch. Now you come to the f0 oblique 0, this interface. So f0 oblique 0 switch port access VLAN 2 is there. In the sense you are configuring the VLAN 2, and f0 oblique 3 I'm talking about this one. So if you are talking about f0 oblique 3, this is also the part of VLAN 2. If you are talking about f0 oblique 4, this is the this is for VLAN 3. If you are talking about f0 oblique 5, switch port access VLAN 3, this is the part of VLAN 3, and switch port access VLAN 3. If you are talking about f0 oblique 6, I am talking about this one. So directly hub is connected. This is also access port is there, right? Now, if you are going to configure the router, so before we configure the router, we need to design our logical network. So logical network is this slash 28 is there, means 240 subnet mask will be there. So 192.168.0. If you're comfortable in subnetting, already I have discussed in my previous session. So it is the network ID, then 16, then 32, and then 48. So we need one IP for VLAN 1, one IP for VLAN 2, VLAN 3, and VLAN 4 to configure. The configuration of router would be then look like this. So how router you will configure, which command you are going to learn to achieve inter VLAN routing. So just have a look. So R1, I am entering into global conversion mode. So first of all, I am going to the first interface at this one f0 oblique 0, and I am putting the IP address, configuring the IP address 10.192.168.10.1 and 255. Here it is 240, right? So this is configured at f0 oblique 0. Then no set command to just make it active. and interface f0.2 means I'm using this, but I'm putting 2 for VLAN 2, right? And well, I will configure the IP address dot 17, and all the host will be having dot 18 dot 19 like that with the same IP, right? So you have to see like once 17 I'm using, and this is the subnet mask of this. Now the things is you are going to configure dot 3 for VLAN 3, and here you see encapsulation. First of all, you have to encapsulate. You have to run encapsulation command for trunk port. So dot 1q2 is there. Then you have to enter into dot 3, and you have to run encapsulation dot 1q3. 3 is indicating your VLAN, right? And you are putting the IP address of this. Then you are entering to dot 4, that is for VLAN 4. I'm talking about this. So encapsulation dot 1q, it is for trunking, and IP address 192.168.10.40.49 is there, and 255.252.40 is there. Right. So this is the configuration at router R1, right? Now these are the so commands, so VLAN, so IP route, so interface, so run, so interface command is there. So these are the with the help of this command you can get all the details of inter-VLAN routing. Thank you guys. So this is about the inter-VLAN routing. Thank you.